Right now, I work as a process and equipment engineer over at Texas Instruments in like the wafer test group. And so before a wafer, like a silicon wafer, gets diced up and like packaged and sent as chips, we first put it through a series of tests. It could be hundreds or thousands of tests on every single die with the use of these really small probes. And that helps us sort out which die chips are good and bad, and helps to allow for the customer for us to make sure that like the customer gets the chips that run the best. My role is like to optimize the electrical and mechanical parts of like the test floor. So it could be like running experiments or analyzing big sets like of data, because we have like about 100 or 200 tools that are running at any given time. I am also part of the recruiting team for TI, and I go to UTD for the career fairs, and I typically try and attend the ones that are for all of the majors, and I help pick the engineers that will come to our company from UTD. The courses that we take very fundamental stuff in all of nature, and in the world of semiconductors, there's a lot of quantum mechanics, there's E&M, there's mechanics, there's thermo. Everything that we cover in our core here is all there. And of course, depending on the role you pick, there's a varying amount of each one of these. But by understanding like the fundamentals, you're able to think through some of the types of issues that we see. And additionally, a lot of programs will just focus more on like on the theory side and like the equations. But at UTD, I feel like there's a lot of opportunity for hands-on work. So we have like a PML lab, where you get to do all types of measurements in like a lab setting, and you write like a report on it. We have like a numerical class for like different types of methods you would use in forms of data science. We also have opportunities to go into like research, and you can meet with like a professor and get some hands-on experience to get better skills or apply your skills in like a setting where you can actually help the world of science in one way. So I really appreciated that. I think the best memory I have is in my freshman year, I got to meet with the late Dr. Hoffman. He made it a point to meet with pretty much every one of the freshmen through a class called The Fun of Physics. I had a professor, Dr. Gardstein, who actually told us it's a privilege to have your main job be to just learn. And I think we take it for granted a lot when we're in school, because we're just trying to get the classes done and we're focusing on the next thing. But if I could give anyone advice, it would definitely be to just sit tight and listen and study to everything, even if it doesn't seem like it is relevant in what you want to do. As Feynman once said, anything is interesting if you go deep enough into it. And by understanding, I guess, like the fundamentals of everything, you will more easily find what is the career you want to go into. And that will allow you to find peers and some mentors that can help you go and chase that. And nothing is absolute. You can always change your path in life, but when an employer sees that you have a background that's in physics, you have proven that you know how to think and solve a wide variety of problems and see patterns. And so a lot of employers will really like that, no matter what field you choose.